Hello, good morning, geometry. How is everybody doing this Tuesday? Sorry I'm not here today, guys. I am away at my training, my monthly training that I go to. So I will be out today, but I will be back on Wednesday, and then I'll be back for class on Thursday as well. Hey guys, don't forget this Friday is a studio Friday, so if you guys need any help or any extra credit, whatever you need to do, any extra work, come in this Friday for Studio Friday. Okay, we're starting off the new nine weeks, the new semester. Finally get to dive into some content today, and I'm sorry that I'm not here for this, but I know you guys like these videos, so I'm happy to do it for you. I know it's very helpful. I can explain stuff. You guys can watch it later if you guys forget any of this information that I present to you, and you get to hear some cool dad jokes. So before we get to dad jokes, how is everybody feeling today on a scale of 1 to 5, right? 1 to 5. I see Diego, good job, thank you for sharing. All right, and then again, it's okay not to be okay. Hopefully everybody's at least around 4s or 5s, but if you're down to the 0s and 1s, I totally get it, right? I understand. Okay, it's okay not to be okay. Just let me know how I can help when I come back. Okay, all right. So today, guys, it is Dad Joke Tuesday, and I'm going to continue off my dad jokes, not from the box of jokes that I got, but from my daily calendar. Okay, so my daily calendar has a dad joke of the day. Since we haven't been in class past few days, the calendar still shows a few jokes, so I'm going to go all the way back to last Wednesday. Okay, so last Wednesday on the 8th, the joke was, what do you call anxious dinosaurs? Nervous Rex. That's probably the worst one. The rest of them are pretty good. All right. This is for January 9th on Thursday. My math teacher, not me, make that clear, not me, not this guy, okay? My math teacher was arrested for carrying a protractor, a calculator, and a ruler. The police charged her with possession of weapons of math instruction. Wow, math instruction. Crazy. Okay, January 10th. My dad has a DeLorean. He only drives it from time to time. Those of y'all that haven't never watched Back to the Future probably won't get it. Back to the Future, in that car, the time machine car, is a DeLorean. This next one is 2 days, right? January 11th and 12th. They combine the weekend ones. All right, so the first one, why did the spoon come to the party dressed as a knife? The invitation said to look sharp. Ha. I love to get involved in winter sports, but I don't know where to toboggan. Toboggan, get it? Oh, I love these dad jokes. Okay, for January 13th, I have a playlist of songs from Eminem, the Cranberries, and the Peanuts. I called it Trail Mix. Ha 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 ha. Alright, last one. This is for today, Tuesday, January 14th. Most puns make me feel numb, but math puns make me feel number. Oh. Okay. Let's see. Alright, so today we're entering into the topic of circles. Alright, circles. Alright, so in circles, well, I guess let's get this thing focused in. And here we go. Whoops. There we go. Alright, so today is the 14th. This is geometry. And we're going to start covering circles. Alright, so circles is typically in geometry like one of the more difficult topics. So if you need to watch this video again, go ahead. This first part's not so bad. It starts getting a little bit more and more complicated when we start going into equations of circles and so on. Okay, so this one is just kind of an introduction. I just want to kind of give y'all a little bit of brief information before we get into the topics and stuff, like some vocabulary. Okay, so we got to go over some vocabulary. Give me a second here and pull up my notes. Okay, so we're talking about a circle. So most of y'all, everybody knows what a circle is, right? Right, there is a circle, right? I drew this dot in the middle because essentially what a circle is a set of all points that are the same distance from the center of that circle. Okay, so it's a set of all dots. You could just and for this you don't have to write this down. I'm just kind of writing it down for the video purposes. Ooh, look at that! Look at the window in my hand. Cool. Okay, that looks cool. All right, it's a set of all points. A set of all points that are the same distance from the center. From the center. Sorry, I'm spelling it something else. Okay. From the center point, okay? So it's a set of all points. So it's a point all the way around from the center. It's the same distance away, right? So if it's the same distance, right, I got all these points that are same distance on there. If I were to draw a dot, a line from here to one of those points, what do we got? We got something called the radius, right? That's the radius, right? It's not the diameter, is the full length, right? Straight across. The radius is half that. Okay? Now, another vocabulary term that we've talked about, you might not have remembered too much of it, but something called tangent. And we just learned tangent in like in our trigonometry topics. Tangent is something that means like touching, right? Like it's. So if I wanted to describe this when we're talking about it in circles, so if I had a circle and then another point, oh man, I can't draw today. So this line would be tangent. Okay, tangent to that circle. It's running on the outside, going all the way through. Okay, so that's what tangent means. Okay, it's just touching one of those points on the outside and going through. Okay, so it really means like it intersects. Maybe say this is a better way. It intersects at exactly one point on that circle. Okay, so it intersects at one of these points. Now we said that it's points all around the circle. It intersects at one of those points on that circle. Okay. Now intersect, right? Again, you don't have to write this down. I'm just kind of giving y'all a little bit of review on some vocabulary. Intersect. Remember, if I had a couple different lines, intersects means just kind of go through it. Okay, kind of go through it. What about perpendicular? All right, so perpendicular. Perpendicular means it makes a right angle. Okay, it makes a right angle. Okay, that's perpendicular. Then you also got Pythagorean theorem. I spelled that wrong. Pythagorean theorem. Pythagorean theorem. There you go. So this is that a squared plus b squared equals c squared. And then I'll draw a little diagram for you too. It has to be on a right angle, right? A right angle triangle. And it could be A, B, C, where C is always the hypotenuse. Okay? C C is always going to be the hypotenuse. A squared plus B squared will equal that C squared. Okay. And then we also got a term called inscribed. Now this is a new one. There's an I in there. This is a newer one, inscribed. So this means a circle is inscribed. What we're going to use is a circle is inscribed in a polygon if the sides of the polygon are tangent to the circle. So inscribed. So circle inside a polygon. All right, meaning it's inside a shape. Right, a polygon is a multi-sided shape. It could be a triangle, it could be a square, whatever. So a circle inscribed a polygon means that if the sides of the polygon are tangent to the circle. So let's say I had a square. Here's a point, here's a point, here's a point, here's a point. So it's intersecting at exactly one point all the way around. Okay? I mean, you could even do this on a triangle. Okay? That would be inscribed. Okay? Now, circumscribed is another new one. Circumscribed is kind of the opposite. So say I got a circle, and then now I'm going to have a polygon inside it. Okay? Circumscribed is in, inscribed is out. Oh, that's going to be so confusing, right? Inscribed is the circle is, well, I guess the circle is inside it, right? The circle, because you're talking about the actual circle, right? Inscribed is the circle is inside. Okay? Inside circle. Inscribed. Circumscribed, it's outside. Okay? It's outside. All right. I hope that's clear. Let's see. I need to grab some water real quick. I'm going to pause. All right, so let's go on with some new material other than these new vocabulary terms. All right, so I talked about tangent. The tangent to a circle So now you can start kind of writing some of this stuff down if you haven't already. If you wrote all that stuff, great. You be ahead of the game. Now is where I really need to focus on some of the new stuff right here. All right. So tangent to a circle. So I'm just going to draw a circle, right? Let's say this is B, point B, and then I have point A here. Okay, I kind of drew it a little bit big and kind of separated so you kind of know, you could see that it's going through the point, and that point is on the circle too. Okay, so you might just see it kind of closer together. I'm just kind of drawing it with a little space on there just so you could visually kind of see how it looks. Okay, so that's a tangent to a circle right here. This line right here. This line is a tangent to a circle. The point of tangency, I don't know if you could see that, is this point right here. That is a point of tangency. Let's see if I can, there you go. All right, so if segment BA is a tangent ray, then point B is that point of tangency. Okay. All right. So now we're going to go into some theorems on this, right? So now we can do different things with this. There we go. All right. So let's say I have a circle here, and I'm going to draw another line underneath so I can see. Let's do our theorem. We have a theorem here that says if a line is tangent to a circle, then the line is perpendicular to the radius at the point of tangency. So we learned a few new terms: tangent. We review a couple of different terms, a review of perpendicular and radius, and then a new one we learned was point of tangency. All right. So let's take a look what that looks like. If if let's say line AB is tangent to circle O, let's see, that's the circle O at P. So I'm going to draw the circle. Okay. Here's point O. There's my radius. This is point P. And then I have a tangent line. A and B. So if line AB is tangent to circle O at the point of tangency, which is P, then AB is perpendicular to line segment OP. So then that means that would be perpendicular. Okay? That means it forms a 90-degree angle. Right? It forms a 90-degree angle. Okay, any questions? You, no? No? Okay. Hey, if there's no questions, then I guess I'll have to continue. All right, let's go on to the next theorem. All right, the next theorem, it says if a line in the plane of a circle is perpendicular to a radius at its endpoint on the circle, then the line is tangent to the circle. Basically what this says is the opposite of what that last theorem was. All right? The last theorem stated if a line is tangent to a circle, then the line is perpendicular. This is if a line is perpendicular, then it's tangent to the circle. Right? So vice versa. A lot of things in geometry work both ways. Right? If this, then that. Well, then if that, then this. Right? So it works both ways. Okay? All right. Here's another theorem. I'm just going to kind of explain it rather than writing them all out. All right. So let's draw our circle. Point in the middle, right? That's point O. And then let's say I have a point here and a point here, and then a point here. So this is B, this is A, sorry, A, B, and this is C. Okay. So if I have a line from here, a tangent line from here, and a tangent line from here, from A to B and from B to C. Now let's see how these are all related. Okay, so if dot 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 line BA and BC are tangent. Okay, it's telling us if they're tangent. I'm telling you they're tangent. Then dot 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 BA is congruent to BC. BA is congruent to BC. Basically, if you want to do this, and we're familiar with tick marks, remember the tick marks, BA is congruent to BC. So they're one and the same. Okay. Let's continue, and now we're going to find angle measurements. Pulling up the notes here. Angle measurements with this. Okay, so here's an example. Example 1. Let's just say example 1. Okay, I'm going to draw another circle. I have point O. Let's say I have N and then L. And then M is way out here. Okay? I have L, M, N, and guess what? I'm going to connect these two. Here's my 90 degrees right there, right? Because remember, it's tangent to the radius. Right? So it's tangent to the radius, so it's going to make it 90 degrees. So, and then this one, angle right here, is 117. Okay? Now I want you all to write something off to the side. All, let's say polygons or four-sided figures, or, sorry, all quadrilaterals. There we go. That's the term I was looking for. Quadrilateral angles equal 360 degrees. So if they all equal 360 degrees, I know I have one that's 117 degrees, right? This one is 90. This one is 90. I am looking for what angle O is now. Sorry, not angle O, angle X. Let's just say X. Plus X equals 360 degrees. So that's how we set up the problem. I'm looking for what angle X is, and I do that by adding all of those up. Right? So 117 plus 90 plus 90 equals, and I'm going to pull up my calculator here. 117 plus 90 plus 90, that's 297. Plus X equals 360. You're going to subtract, and you should get X equals 63. Okay, so that equals 63. All right, now I'm going to give you all one to try on your own. Okay, I want y'all to try this on your own. ED, let's do example 2, is tangent to circle O, find X. Okay, here we go. O, D, now I need to find that one. Okay, and it says ED is tangent to O. All right, so tangent to this. Right, so what do you know if it's tangent to the radius? And I want to find angle X, which is this angle right here, and this angle right here is 37 degrees. Okay, now you can pause this, or if you want, if you're working on yours by yourself. If not, you're working in class and you're watching this in the classroom, we'll continue on it, right? So I know if it's tangent, that means that's 90. So 90 plus 37 plus X equals, and it's a triangle, not a quadrilateral, so this is all going to equal 180 degrees. So 90 plus 37, I'm just going to pull up my regular calculator. 90 plus 37, and then I'm going to subtract 180 from that. This is 127, and that's 53. I'm writing it out here just in case. Minus 127 minus 27, and X equals 53. Good job, everybody. All right, next problem. Okay, I got room here. All right, pulling up the notes. All right. Example 3. Let's draw another circle. There's the center. This is C. This is B. This is A. So I got A, B, C, and now I want to put some. I'm going to put some numbers in there. Okay. And the question is, find the radius. Okay. So what I need to find the radius, which is X. Let's say this is X right here. Okay. This portion is X too because it goes from here to here. That's the radius too as well. The rest of the way is 8, and this whole entire length is 12. Now, also AB is a tangent, so that means, and I'll do it in red, this is a 90-degree triangle. Okay? So I have a 90-degree triangle. I know one side of the triangle, kind of know part of the second side of the triangle. We can use the Pythagorean theorem in this instance. Okay? A squared plus b squared equals c squared. A squared plus b squared equals c squared. C squared is going to be the hypotenuse, right? So, but I know what you're saying, Mr. E, I don't know the entire length of C yet. We don't. But this is how you set it up, right? I have, let me get a different marker color. Let's say this side is A, this side is, oops, this side is C, and then this inside is B, okay? So I'm going to do it in red here. I got A squared plus B squared equals C squared. Now, C squared will be x plus 8 squared. Actually, it's just x plus 8, no, yeah, x plus 8 squared. Okay, so I got to do those two together. All right, so x squared plus 12 squared is 144. Now this is the tricky part. Now you got to FOIL this out. Okay, which is basically x plus 8 times x plus 8, right? That's what squared is, times itself. Okay, so times itself, x times x is x squared. That's x times 8 is 8x, and then another 8x, and then 8 times 8 is 64. Now I combine all that, and there we go. I have x squared plus 16x plus 64, which is in terms equal to 144 plus x squared. So now we just got to work a little magic here and start crossing some stuff off, right? If I subtract x squared, that cancels out. Okay? If I subtract 64 here, 144 minus 64, type that into your calculator, should be 80. Let me see. 144 minus 64, 80, yes. So that's 80 equals 16x. So now let's divide 80 by 16, and I get x equals 5. So that's my radius. Okay, a little bit more work, but it is just kind of work it through. And I know what you're asking, how do I know when to use that Pythagorean theorem? Well, you use it when you see that there is a 90-degree angle there. Okay, there's a 90-degree angle, and it's just missing some sides. Okay, all right. Here's another one. I'm going to give you all another example to try on your own. What is the radius of circle O Sorry, my pen moved. There's like something underneath this paper and it kind of made it an egg shape. Looking for the radius. Now go. All right, set it up. A, B, C. X squared plus 10 squared equals x plus 6 squared, which is x plus 6, x plus 6, FOIL out. Okay, I'm just foiling it out. Combine those like terms and now you have x squared plus 12x plus 36 this is basically 100. Cross out your x squares, and now I have 100 equals 12x plus 36 minus 36 gives me 64, and then 12 divide by 12. Probably going to get a decimal. .3. Okay. Almost done, guys. Almost done. Let me make sure. Next example. Next example. Let's go example 4. Alright, so we're going to draw another circle. Now it's going to ask, is ML tangent to circle N at L? Okay, so now it's the opposite, right? Now we're just going to try to figure out if it's tangent. So I got N right there. This is L. Point M. And then here's the values. This is 7. This is 24. And then this is 25. So we're trying to see if it's a tangent right here. Okay? And the way we can figure out if it's a tangent, well, if it's a tangent, then it's got to be a 90 degrees, right? It's got to be perpendicular. Okay? Now, if it's perpendicular, if it's a 90 degrees, then the Pythagorean theorem would work. So let's see if the Pythagorean theorem would work. So that would mean that would be the 90 degree. So this would be the hypotenuse. So 7 squared plus 24 squared should equal 25 squared. Remember, you got to identify that perpendicular line so that is the 90 degree, and so you can identify which one is the hypotenuse. The hip hop anonymous. That's my rapper name. Hip hop anonymous. Like Doug Judy, right? Just Doug Judy from 9-9. Doug Judy. Okay, so 7 squared, 49, plus 24 squared. Let me do that in the calculator real quick. Should be 24 squared is 576. So if I add that to 49, that is 625. 25 squared is 625. So they are equal, so yes. So they are congruent, or that is a tangent. Okay? All right. Let's see what else is next. I think I'm looking at your assignment. I think we might be ready. Oh, hold on. Let's go to the, okay, on the back side there's going to be some inscribed circles. Okay, so let's go over the inscribed. We didn't talk about inscribed too much, but I want to talk about inscribed. So example 5. O, circle O, is inscribed. INS, right? INS scribed in triangle ABC. What is the perimeter of ABC? Okay, of the triangle ABC. So let's see. I'm going to draw my circle. And then now I have a triangle. Sorry, it's connected. It's touching right there. Okay. This is A, this is B, this is C, this is D right here, this is E, and this is F. Okay. Now let's put some numbers. Okay. This is 10, this is 15, and this is 8 right here. Now, if you remember when we're talking about tangent lines, they are congruent, right? Remember, tangent lines are congruent. If 2 points connect to the same endpoint, this line and this line are congruent to each other because they connect at the same endpoint. So those two are congruent. Same thing right here. These two are congruent. Same thing right here. These are congruent. So if that's the case, if this is 15, this is also 15. This is 8, this is also 8. This is 10, this is also 10. Now I just have to add all those up. So 10 plus 10. I'm going to do it vertically. Plus 15 plus 15 plus 8 plus 8. Now add them all up. 10 plus 10 plus 15 plus 15 plus 8 plus 8, and my perimeter is 66. Okay. Believe me, there's a little bit more. Okay, there's a little bit more. Almost done. I know this is a long video. Oh, hold on. Got the last one. Okay. So you're going to have some problems. This isn't exactly problem 5, but this is going to be, you could say example 6. Let's just do example 6. Okay. Draw another circle. I'm going to draw it just like I did over here. Same thing. Okay. So let's say I know this is 17. This is 15. This is 0. This is point X. This is point Y. And I need to find out what's the length of QY. Okay, and then the perimeter is 88. Okay, I need to find out what the perimeter, what the length of QY is. Oops, I forgot to put Q. So this is P, R, and Q. Okay, So the perimeter is 88. I know this is 15, this is 15, this is 17, that's 17, but I don't know what that is. Okay, so let's do 15 plus 15 plus 17 plus 17, and then this is, let's just say, T. Okay? Plus T equals 88. That's basically 2T. Okay, I'm combining those two. Okay, that's 2T. So let's add them up. 15 plus 15 plus 17 plus 17 equals 64. Plus 2T equals 88. Subtract 64. And you get 2T equals 24, which means T equals 12. So each side should equal 12. Alright, y'all. Kept y'all here long enough. Go ahead and do your questions here. Don't worry about 4, 5, and 6. Don't worry about 4, 5, and 6. You guys can do the rest though. Okay, this one's a little bit more complicated, but don't worry, you guys can do it. Use the Pythagorean theorem here. And then you got the circumscribed of a circle. Okay? The inscribed. Okay, you guys can do it. Alright? Look at 17. B is inscribed in a triangle, which has a perimeter of 76. What is the value of x? We did one just like that. Okay? Don't get confused. Alright, that's all I have for y'all today. See y'all Wednesday and Thursday. Hey, in case I forget, don't forget to hit that like and subscribe. Look out for some merch. Buttons coming up soon.